Momentum means the amount of motion an object has. Put your pencils down, look up. Demonstration, but I think the amount of motion an object has is going to depend on two things: its mass and its velocity. So I've given you these little diagrams, the amount of motion, large or small. So you can imagine here, ping pong ball traveling slowly. David, you were a guinea pig. Lots of motion or small amount of motion?
Small.
What if I fired that ping pong ball out of a gun? Higher velocity, more motion or larger motion? Yes? A big mass with a small speed can still have more motion than we've started with. The worst are big mass and high speed. A locomotive crashing into a standing car has a lot of motion. Big mass, high speed. A cannonball has a lot of motion, or an artillery shell. Big mass and very high speed. So, most. It says explain your answer. I think we did by playing catch earlier, you and I. Is that okay? Momentum depends on both mass and speed. Cross out the word speed. I need to replace that with the word velocity. Which one is the vector? Velocity or speed? And momentum, the amount of motion, momentum is a vector. Okay? So you're going to also notice I'm going to become way more careful again with my positives and negatives and which way things are going again. We call it the motion product. Now we'd like to, for momentum, use the letter M, but what's the letter M already taken by? Mass. So we're going to use motion product. We're going to use the letter P. I'll put the vector sign on there to remind me, Christy, that motion, momentum is a vector, direction matters. And it is mass times velocity, not speed. I should have corrected that, Christian. And I put the vector symbol above velocity. In fact, the direction of an object's momentum will match the direction of its velocity. That's where it gets its direction from. What would the units be? What are the units for mass? Kilograms. What are the units for velocity? What are the units for momentum? Kilogram meters per second. Now that's a bit of a mouthful, and often for longer units we give them a special name. For example, a Newton was actually a kilogram meter per second squared because it was a mass times an acceleration. They haven't given this one a name. They are talking about naming kilogram meters per second and Einstein, because he doesn't have a unit named after him, and he probably should. That may happen in your lifetime. There is actually an international governing board that defines what units are and what we call them. Believe it or not, that's something that exists in the world. And so they're talking about renaming this in Einstein. But for now, momentum is measured in kilogram meters per second, which is kind of nice because that tells you the equation. Or, if you forget the units, it's hidden in the equation. Little nerd trivia. Kilogram meters per second works, but also Newton second works. What? So if we write down capital N dot times S, Hannah, coming back to you, F equals what? So a Newton is actually M kilograms, A meters per second squared, and then if we times that second back on, Maggie, how many S's are on the top there? How many S's are on the bottom? Can you see this S cancels out with that, and I'm left with a kilogram meters per second. And so you're going to see sometimes we'll talk about the amount of momentum and we'll use Newton seconds. Sometimes we'll use the amount of momentum as kilogram meters per second. Brian is asking, which one is correct? I don't care which one you use. I will probably use the slightly more correct one in certain contexts, and you'll just see I'll do it intuitively, and I'll explain to you why I am. But for now, what are the units for momentum, Dylan? Kilogram meters per second. What are the units for force? Kilogram meters per second squared. Or, you know what, a Newton. Okay. since I've just introduced a new concept to you, momentum, I always try and give you an idea, Rihanna, of what's really big and what's really small. So we're going to estimate the momentum of a top pitcher's fastball. Then we're going to estimate the momentum of a person and bicycle on a relaxed ride. We're going to estimate the momentum of a car driving on a city street. So, do I have any baseball players here? No? No one. What's the mass in kilograms of a hardball? Let's see if we can figure this out. Is it 1 kilogram? Or is that way too big? Rihanna says that's way too big. In fact, I think it's less than half a kilogram. You know what? Ballpark figure, I'm going to go with about 1/4 of a kilogram. It's a little less than it's under a pound, and I know there's 2.2 pounds in every kilogram. Okay, so I'm going to estimate the mass. M equals, you know what, Mr. Dewick, don't use a red. M equals 0.25 kilograms. Now, this does say the momentum of a top pitcher. Does anybody watch baseball in the major leagues? What do the top pitchers occasionally peak out at? And you'll probably have to give me an answer in miles per hour, but that's okay. But it's a nice round number. What can the top pitchers hit occasionally in miles per hour? 100. I need to convert that to meters per second. Okay? I have a bit of a shortcut. I know that 100 miles per hour is, if you divide it by 2, that's roughly meters per second. But wait a minute. That's what Google is for. I'll use my phone for something useful, Tim. Convert 100 miles per hour to meters per second.
100 miles per hour equals 44.704 meters per second.
What's a nice round number close to 44.7? Let's go 45. Heck, you know what? Let's go 50. Okay. We're estimating. So let's go. How much momentum does a major league fastball have? Vic, 12.5, but double check me. This is where you get your calculators out and start typing, by the way. Thank you, Tristan, for finally getting your calculator out. I noticed. Is it 12.5? Yep. What's our symbol for momentum? What letter, what variable? P with the vector sign is 12.5 kilogram meters per second. Let's go back to David, with whom I played catch earlier. David, if you were at bat in the major leagues, as long as it doesn't hit you in the head, if a fastball hit you on your torso, will you die? Will you have to go to the hospital? No. Will it hurt? In terms of absorbing momentum in a collision, ouch. 12, you know what? Roughly 10, if I really want it to be rough numbers. 10 meters per second. If you have to absorb that all at once, you know what, Joel? You'll probably be rubbing that area for a little bit, but as long as it didn't hit you in the side of the head, ouch. Bike and rider, estimate the mass. Okay. What do you think the mass of a bike and rider is? 500 kilograms? No, way too big. Okay. What's the standard mass of a human being in kilos, roughly? And by roughly, I mean, let's just see if we can even get within one sig fig. 100 kilograms? 100 kilograms, I think it's 2.2 pounds per kilogram. That'd be like 220 pounds. I think even that's a little high. But you know what? We got the bike as well. Sure, let's make this a lighter person with a heavier bike. A nice number to use. Rihanna is nodding with me. Sure, let's use M equals 100 kilograms. Then even Rihanna can do that math in her head, I'll bet. Speed. Does this question say the bicyclist is just giving it, going really, really fast? Okay, relaxed, it says. What's a relaxed speed on a bike? And you can give it to me in kilometers per hour or whatever. We can do a conversion if we need to. 50 kilometers per hour? In fact, what speed is 50 kilometers per hour? Car speed, so that's not relaxed. Half that? 25? I think that's still probably pretty quick, I think. 15? 15 kilometers per hour. Ready for our beginning of the year review? How do I go from kilometers per hour to meters per second? It had something to do with a 3.6. If you're lucky, you put that on your formula sheet somewhere. Is it divide by 3.6 or times by 3.6? Is it divide? So can you go 15 divided by 3.6? What do you get? Yuck. 4 point what? Let's just go 4. Because we're estimating, yes? Rihanna, in your head, what's the momentum of a bike and rider that are just casually biking along? Yes. If you were walking down the sidewalk and a person on their bike going fairly slowly runs into you, will you die? Probably not. Might you break a bone? Possibly. Absorbing this much momentum all at once, Emma? Probably injury. Car. What's the mass of a car? 100 kilograms? Million kilograms? What's a nice round number, rough guess for a mass of a small car? Let's go 1,000. I'm good with that. Sure. Because then even Cole can do the math in his head. It does say driving on a city street. What's the speed limit on a city street in kilometers per hour? 50. How do I change that to meters per second? Go ahead. What do you get? 13.8. You know what? I'll pick a nice round number, 15. We'll go, because people, first of all, nobody does actually 50. You figured that out. Everyone speeds a little bit, yeah? So can I go 15 meters per second? Cole, how much momentum does a car have going down the street? Probably not survivable if you absorb it all at once. Now, one of the things we're going to talk about is, are there ways that you can spread out the momentum absorption over time? Yes. We call them crumple zones. That's what cars are designed to do. But absorbing that all at once would not be a good thing. So 12.5, what's a really nice round number close to 12.5? 10 kilogram meters per second. You can probably shrug that off. It hurts. But, eh. 400, 500 kilogram meters per second, you're probably saying some bad words. Maybe having to go to the hospital, maybe break a bone. But you're still, if not shrugging that off, eventually you'll be walking. 10,000, 15,000, Brian, we're getting some nice cards for you, and you may survive, but you're going to be in the hospital for a while. There's the mass of a baseball. Nobody read down. So I said, what, 0.25? I'm a little high, but close. Okay. Baseball of mass 0.14 kilograms is moving at 35 meters per second. What's its momentum? Oliver, this is our new equation. What's our new equation for momentum? First of all, what letter are we using for momentum? Why not M? It's already taken. YP, product. And what's our equation? What times what? That's right, M. Good, good. And then the second letter? Yeah, there you go. You were giving me a hint, right? With your Yeah. Of course you were. Oliver, what's the mass? Yep. And what's the velocity? 35. So this is probably a more accurate non-guesstimate of a Major League fastball. 35 meters per second. Can you multiply that by 3.6? How many kilometers per hour is that? Someone quickly do that on their calculator? Anyone? What'd you get? How many kilometers per hour is it? Someone please go 35 times 3.6, unless you want to have more homework for the weekend, because I'm not doing it for you. Sorry? 126 kilometers per hour, which I've driven in the U.S. enough to know 120 kilometers per hour. I know 100 kilometers per hour is 60 miles an hour. That's probably about 75, 80. This is fast, but not screaming fast. What'd you get when you went 0.14 times 35? 4.9 even? Units, Oliver? What are the units for mass? No, that's the variable. What are the units for mass? Kilogram, and the units for velocity, meters per second. They may rename that in Einstein in your lifetime, but you're not allowed to write a capital E yet. They're talking about it. David and I played catch with a bowling ball earlier. How fast would I need to throw the bowling ball so it has the same momentum as the baseball? David, what's this question asking me to find? Part B. So you ready? Hopefully now all my plans come to fruition. Could you please rewrite this equation and get the V by itself, or do I have to actually give you a brand new equation? Can you get the V by itself? What does V equal? What's the M doing to the V? Adding, subtracting, multiplying, or dividing? So how will I move it over? How will I move the M over? I'm looking for where it begins with the letter D and rhymes with ava. There we go. So the P stays where... Whoop, this is just moving around on me. The P stays where it is, and you're telling me I divide by the M? That's what you said, right? Of course you did. So the momentum that they want us to have apparently is 4.9. The mass of a bowling ball is 7.26 kilograms. I think it's a 12-pound bowling ball, I think is what I converted. I can't remember now. How fast would I need to throw it? Definitely less than 35 meters per second. Do you get 0.67 blah? You know what? I'll go 0.675. Yes? Units, David? No. What did we find? Careful now. Because we found a... Because what did we find? Yeah, meters per second, right? Now, really for it to be a velocity, I should have given you some kind of direction thingy. I didn't. Sue me. Turn the page. I like example 3. I like example 3. Example 3 is the next question. Brian, what does example 3 want me to find? Oh. How do I calculate momentum? Yep. Cool. Did they give me the mass? Yep. Did they give me the velocity? Ooh. What else did they give me? Okay. So even though this question wants me to find momentum, you know, I'm going to spend most of my time finding, I think velocity. Okay. So let's do that. And let's write down V equals question mark. What does dropped tell me? What do we say instead of started? We have a fancy physics term for this. Oh, which means I think I'm actually being asked to find V final. Okay. What else do I know? Oh, what's the acceleration? Now we're back to vector land. Now and this is why I said at the beginning of this lesson, I'm going to be more careful now with negatives and positives. This is also great review because we are in the home stretch. What else do I know? Oh, I had such high hopes. Are we ending up above or below from where we started? Yes. Lots of room to make sloppy mistakes here, but coming back to us. Hey, I'm looking for an equation that has a VF, a VI, an A, and a D. I bet you there is one. How would I get the VF by itself? You told me VF squared. Yep. So it's going to be big square root of vi squared plus 2ad. If I was really lazy, I probably didn't even need to bother writing the vi squared. And this, by the way, is why you had to have those negatives in, because, Brian, most kids would have got the negative 9.8, but if you put a positive 75 in, you're trying to take the square root of a negative, and your calculator barfs at you when you do that. That's why you have to have that negative there, because a negative times a negative is a... Are you positive? Okay. So it's going to be 2 times negative 9.8 times negative 75 square root. You get 38.34, blah, blah, blah. I'm going to write 38.3, but you know I'm using my answer button on the next line, yeah? And I'm wrong. Why am I wrong? Why must this be wrong? It's got to be negative, because which way is the rock traveling when it hits the ground? Not up. This is where we said when you hit that square root button on your calculator, it always assumes you want the positive answer. But in physics, sometimes we want the negative square root option, please. Thank you very much. Okay. So what's the momentum? It's going to be the mass times the velocity. Except I'm not going to use 38.3. I'm going to use my answer button. 12 times answer button. Now, if you can write negative 460, I'm fine with that. Units, Brian, for momentum? Yep. Are you starting to see why I also told you it was worth memorizing units? Because you can figure out the units just because you know mass and velocity. Or you could write 460 kilogram meters per second direction. What's the negative really mean? I'd take that too. What I wouldn't take is negative and down, because what's negative down technically? I would argue it's up, so don't pick one or the other. Which one's less writing? Yeah, let's go with the first one. What's your homework? So short intro. This used to be a much bigger, longer lesson in 80 minutes, but I've split it up into 2 smaller ones. This gives you time for it to percolate. And you guys got a long weekend, and believe it or not, as much as I damage your self-esteem, I do like you guys and want you to have a free long weekend. What's your homework? Absolutely number 1. It's going to be almost every question, I think. You know what? Instead of circling, I'll cross out which ones I don't like. I'm good with 1. I'm good with 2. I'm good with 3. I'm good with 4. Good with 5. 6 is good. 7 is good. 8 is good. 9 is good. 10 is good. 11, 12. You know what? I'm good with all these.